The industrial and manufacturing market uses an abundance of electricity to manufacture products and goods. Energy efficiency has become one of the key performance indicators for most corporations. Reducing the amount of electricity consumed in a building results in substantial savings. Plants have been upgrading to more efficient technologies to reduce their consumption. The trouble is, energy efficiency equipment like VFDs, fluorescent lighting, and others create nonlinear loads on the system. These nonlinear loads result in harmonics in the system. The increase in harmonics will lead to energy losses, excessive heating in equipment and conductors, misfiring in variable speed drives, and torque pulsations in motors. A comprehensive analysis of an electrical system can identify inefficient and damaging characteristics that can negatively contribute to overall production and operational costs. The analysis includes metering at each substation as well as individual loads throughout the plant, identifying problematic areas that are experiencing harmonics, voltage, and current imbalances, as well as lower power factor. If these problems exist, the Energy Services team can assist by outlining projects that will treat these inefficiencies, either dynamically or statically, depending on the severity of the problem. These systems are built to ensure that the power factor is greater than 99%, also that there's no voltage or current sags, and to mitigate any harmonics in the system. As equipment within the operation varies in startups and use, voltage supply can often be impacted and sag significantly. This often affects the performance and efficiencies of the equipment throughout the facility outside of its optimal range. By both raising and stabilizing the voltage supplied to all equipment throughout the plant, equipment performance, productivity, and efficiency is significantly improved. Oftentimes, plants will believe they're taking necessary steps to improve their power quality because they've cleaned up the power factor in the past. Because electricity is a closed-loop grid, the plant will use electricity along the line, and what is not used is delivered back to the grid. Because there are numerous users along the way, the power factor will tend to decrease as electricity makes its way through the site. When dirty power is returned to the grid, utility companies will often penalize businesses. In order to remove this penalty, plants will treat the power as it leaves the building, but they don't take into account the poor power quality they are using in their equipment. The Energy Services team will ensure the power is treated before use, safeguarding reliable power at each load and as it leaves the plant. Not only does it rid the plant of the poor power factor penalty, but it also allows equipment to run more reliably and efficiently. All problems with systems will be comprehensively described in a report. Projects will be outlined to fix these power quality problems, and a complete return on investment report will be included with full turnkey installation costs. Incentives available by the utility companies will be managed by Motion Industries. There is typically energy savings around 4 to 8% or more. This is a significant dollar amount, but this tends to be a small fraction of the actual impact of improving power quality. Since electricity will be more reliable, there will be less heat in the equipment, resulting in motors lasting longer, drives lasting longer, and increased uptime. All the qualitative benefits of power quality are the frosting on the cake of energy savings. From all of us here at the Energy Services team, thank you very much, and we look forward to working with you.